This video is about exponent rules. So in this video, we'll talk about the general product rule for exponents, the general quotient rule for exponents, and also the general zero rule for exponents. Let's get started. Let's start with the basic understanding of what exponents even are. Okay, if I write 2 to the third power, what that means is 2 is the base of the exponent, and I'm multiplying that number 2 by itself the exponent number of times. So that means it's 2 times itself 3 times. 2 times 2 times 2. Okay, that's what's meant by 2 to the third power, or 2 cubed, is 2 times itself 3 times. Now, the general product rule is x to the m power, meaning x times itself nm times x to the n, or x times itself n times, and what you'll get is x to the m plus n. Now, let me give you an example of that in letter A. I have x cubed, which is x times itself 3 times. And I will multiply to that x times itself 8 times. So really, I have 3 x's, or I'll put it in a grouping symbol this way, times 8 x's, but really it's just a bunch of x's. Okay, how many x's? Well, it's 3 plus 8 x's, or 11 x's. So I have x times itself 11 times. Okay, the general product rule is where you keep the base and add the exponents of the common base. It's important that you have the same base in order to be able to use this rule. Okay, so if I have in letter B 2 to the fourth times 2 squared, I have 2 times itself 4 times, 2 times itself 2 times, or 2 times itself a total of 6 times. Okay, so that's really it. Okay, in C, it just gets a little more complicated with having both x's and y's. Again, this phrase right here, the common base, is important. Okay, I will multiply the x's together. X squared times x cubed. I have a common base. I will keep the base, and I will add the exponents. 2 plus 3 is 5. Okay, now for y, I have y times y to the fourth. So I have the common base, and it's not written, but I really have one y. So y times y to the fourth is the common base of y. Now, how many y's do I have? Well, I had 1 and then 4 more. So in total, I had 5 y's. Okay, in letter D, I have even more stuff there. So I have these numbers 2 and 3. 2 times 3, I know we're kind of used to adding numbers right now, but the numbers 2 and 3, you'll still multiply them. It's just exponents that you add. So 2 times 3 is 6. Y squared times y cubed. You keep the base of x, and you add the exponents. 2 plus 3 is 5. And y times y to the fourth, you keep the base. You add the exponents 1 plus 4, and you get y to the fifth power. Okay, that's the general product rule. You keep the base and add the exponents of the common bases. Okay, so in the general quotient rule, it is x to the m divided by x to the n. And that's going to be equal to x to the m minus n. Let me give you an example of that. In letter A, I have x to the fifth power, which again is x times itself 5 times. And I'm dividing by x squared, or x times itself 2 times. Now, because I'm dividing, I can cross cancel. I can cross off the common multiples. I can cross off 1, 2 of them. Okay, how many are left? Well, I have exactly 3 that are left. So I have x cubed left. Okay, which means that if I have x to the fifth on the top, right, 5 x's, I can cancel off exactly the number I have in the denominator. Okay, so that equals 5 minus 2, because I'm canceling off 2 of those off the top of the 5. Okay, so in general, you will keep the base just like before, but now you will subtract the exponents of the common bases. Again, common bases are important, but we will now subtract. And the one thing I'll add to this, I will add that it's top minus bottom. Okay, just like here, 5 minus 2, it's top minus bottom. Okay, in B, there's 2 ways I can think about it. I can think about the general quotient rule. I will keep the common base of x, and I will subtract top minus bottom, meaning 3 minus 5. If I take away 5 from 3, then I go negative 2. Okay. The other way to think about it is this kind of division, writing it out, x times itself 3 times, x times itself 5 times. I can cancel off 3 of them. I'm left with 2 in the denominator, right? In the denominator. So I have 1 over x squared is the other way to write this one. And that's exactly what the negative exponent means. So I think it's kind of helps us understand what negative exponents really mean. It means it's 1 over, that base to the exponent. In letter C, I have 3 to the 5th power divided by 3 cubed, and I'm just going to keep the common base of 3. I will subtract the exponents. 5 minus 3 is 2. That's it. Letter D, I have more things going on, and I'll think about these in terms of the common bases. First, these coefficients, 8. Now, we've been subtracting, but I'm still dividing these numbers. 8 divided by 2 is going to be 4. Okay, looking at the x's, I have x squared. I have 2 x's divided by x to the 1st power. I will keep the common base. I will subtract the exponents. 2 minus 1 is 1, or just leave it x. And then with y, I have y to the 5th divided by y to the 3rd, common base. 5 minus 3 is 2. So if I divide this out, I get 4xy squared. And only y is being squared, so it's 4xy squared. That's the general quotient rule. Now, the general zero exponent rule is that any base except 0 raised to the 0 power is equal to 1. Okay. Now I know that if you're thinking about, the base times itself the exponent number of times, that makes a lot of sense. It breaks down with negative or 0 exponents, but the pattern is still there. So if you think about it, if I have, let's say, 2 to the 1st times 2 to the 2nd times 2 to the 3rd, then I get 2 times 4 times 8, and I'm seeing a doubling pattern that happens. Right? 2 to the 4th would then be 16, right? So going this way, I see a doubling pattern that happens. If I go backwards, I see divide by 2, or half. Well, what's 2 divided by 2? What's half of 2? And I get 1. So 2 to the 0th, to follow the pattern, must be 1. This also leads you into negative exponents, which is 2 to the negative 1 half. Sorry, negative 1 first power. Anyway, the point of that is that it matches the pattern that we have with multiplication, okay, where you have anything to the 0th power is equal to 1. So y to the 0th is 1. No matter what y is except 0, whatever the y value is, that number to the 0th power is 1. 6 to the 0th is also 1. Okay, and in parentheses, 7a cubed b to the negative 1st, as long as a and b are not 0, that will also be equal to 1. Okay, in letter D, we have 3 times 7xy to the 0. This piece of it becomes 1, and 3 times 1 is 3. Okay, that's the general zero exponent rule. Okay, now I'm going to do some of these down here. Let me do just the evens of the ones down here. Okay, so I'm using these rules for new problems. I'll talk you through these. So in number 2, I have x to the 5th times x to the 3rd. Keep the common base, and I will add the exponents. 5 plus 3 is 8. Okay, number 4, 6 to the 5th power divided by 6 cubed. You keep the common base, and when you're dividing, you will subtract the exponents, top minus bottom. 5 minus 3 is 2. Okay, number 6, 6 divided by 2, just dividing those, is 6 divided by 2 is 3. And then x to the 7th power divided by x to the 4th power, these are the common bases. I will subtract the exponents, top minus bottom. So 7 minus 4 is 3. Okay, number 8, I have a 0 exponent. So this thing right here gives me 1, and then I have a negative 1. Okay, number 10, I'm looking at the common bases. So first x. So x to the 5th divided by x, 1x down there at the bottom. I will keep the common base, and I will subtract 5 minus 1 and get 4. Okay, now a new thing will happen for y. I'll have a negative exponent that I'm dealing with, but it's the same pattern, the same general rule. Okay, y to the 6th divided by y to the negative 2nd. I will keep the common base of y. And then I will do the top minus the bottom. 6 minus negative 2 is 6 plus 2, because taking away negatives is the same as adding that as a whole number. So 6 plus 2 is 8. All right, in number 12, I have the same base, j, and I'm multiplying. So I'm going to add the exponents, and I get j, I get negative 13 plus 4 plus 6. Okay, and negative 13 plus 4 is, let's see here, negative 9, plus 6 is negative 3. And that's it. This video was about the exponent rules. We talked about the general product rule and the general quotient rule and the zero rule for exponents. Thank you for watching.